Hey guys, today I'm going to be talking to you all about how to do this circuit problem. It's a pretty standard problem. You have this device D with a current going through it and a voltage that they're measuring. And I'm going to break it up into 4 parts just so I don't make the video too long. So for part A, it asks, that is a terrible A. There we go. For part A, it asks, find the power delivered to device D at 2 milliseconds. So the way we do that is power delivered or absorbed depends on which way the current is going. If it's going from the negative terminal to the positive terminal, like this one, power delivered is going to equal voltage times current. Okay. The power absorbed in this case would equal minus voltage times current. Okay. And if the current was going the opposite way, obviously those would flip. So they're asking us to find the power delivered, so we use that formula. Power delivered equals VD, which is at 2 milliseconds. VD for us is going to equal 2 volts from the graph. And ID is going to equal this formula that they gave us. So 15 milliamps times E to the minus 0.02 times T. And so this 1 over milliseconds here, that means that in order to cancel that out, our T has to be in milliseconds also, which it is. And so that is no problem. If it wasn't, if it was, say, in seconds, we'd have to convert it to milliseconds. So we have the 2 milliseconds over here for T, okay? And once, now we plug all this into a calculator. So we get power delivered to be 28.824. Something, right? We have to put the units. And for the units, standard units for power are watts, right? And that equals volts times amps. But in this case, we're multiplying volts times milliamps. So our units are going to be milliwatts. And there you go. That's how you get power delivered / absorbed.